Hello guys, thank you for joining us in this day. My name is Filipi Pires. I am talking from Brazil, and today we're gonna talk about a very interesting topic that I like a lot. This topic is malware analysis, and of course, I chose to talk today about the PDF malicious. And so, yeah, let's start. Let's begin, and let's start the presentation. Right? Let me share my screen here with you, and we're gonna talk about discovery CNC. It's a command, it's a acronym, right? It means command and control in a malicious PDF using a disobfuscation, encode, and other techniques, right? So let me share here my contacts on social medias. If you'd like to follow me or maybe send me questions, I use it a lot on LinkedIn, sharing the papers and articles as well in Twitter. And I have some projects in GitHub, if you'd like to see, that I talk about the security and threat hunting. So if you have some questions or doubts, you can send me a message if you want, of course, right? And let me introduce myself. I am a security research and security developer advocate at Soup Innovation. Soup Innovation, it's a Brazilian company, right? And we have a simple purpose. By the way, I will show you about the website about my company, right? So I think we have this good definition here by one of our founders, right? At Soup Innovation, our main purpose is to create an exponential growth environment. It provides a lot of opportunities to evolve your career, right? And here I would like to share with you, we responsible to create many open source products, right? We have, by the way, 4, Reach, Charts, and Beagle. All those products, it's open to the community because it's open source, of course. And I'm advocate of the ORSEC, right? ORSEC is basically performing static code analysis in your code to try search a possibility or any possible vulnerability in your code, right? And binaries and many things that you have in your project, right? Let's return here. I am advocate at Hacking is Not a Crime. It's another very interesting project that I am participating, right? I am sharing here a simple definition about this project. This phrase is a good definition, right? Contrary to the population misconception, behind a hacker is a lifestyle, sorry, and mindset. Because usually this expression, a hacker or hacking, many times the media using it the way around, right? Like a bad guy. It's not correct to use this. You can use a threat actor or maybe an attacker, but never like a hacker, right? Because as I mentioned, it's a lifestyle, is a mindset. It's not a fashion statement or a move character, right? Hacker is a simple, curious, and outside of the box thinker who creates unorthodox solutions for every problems, right? The actions and the method by each of these problems are solved is called hacking. That is a simple and correct definitions, right? So I am an advocate of this amazing project, and I am a part of the staff team of the DEFCON group São Paulo. It's a very, very good group here, part of the DEFCON groups. I think you know about this DEFCON event, so it's very interesting. We have this kind of group. We have a Discord. If you'd like to, we participate with us. We are open to talk with you because over there, we share acknowledgement, we share the videos, we share demos, we share contents, many things that you can imagine because it's a community, right? And I am a security research and instructor at Hacker Security. It's a Brazilian company, and I am instructor of the malware analysis courses, fundamental courses, and we have their penetration test courses and something like that, right? And I am a writer and reviewer of these magazines, and Pentest magazine, Hack9, and a forensic magazine. So this is information about me, right? So let's talk about our summary or our agenda, right? So first we understand who is a threat, because I would like to put all those in the same page, right? I think it's very important. And after that, we gonna talk about more analysis, and we need to understand, we go to understand about the structure of the PDF. I will do the demo in the end of this explanations. In the end, if you have any questions, I will hope to answer to you. Right. So, who is threat? It's very important thing here, because in security we have many different explanation or about this word, the simple word, right? So I just chose one of this, right, based on according to this ISO, right? So threat is a definition, has a potential cause of the incident that may cause harms in the system and organization. And here we have an interesting point. Maybe threat can be it's a software attack or a theft of intellectual property, identity theft, of sabotage, or not, and information extortion are example of the information security threats. As a result, most of the many organizations chose active threat hunting to practice to defend their organization from the network no threat. So that's a good point here. So maybe you can think now, so Philippe, so actually the threat is almost everything. Maybe as, of course, related to a softwares or attacks. Of course, we have a physical attack as well. So in this case, it's almost different, but in the end of the day, the concept is almost the same, right? The attacker will, attack something, a software or a people, right? That's an important thing here. So the first step when I will execute some analysis, the first idea I have, of course, a sample. Because I don't know if malicious or not, right? So I have a sample and I need to analyze this. And the first step and the first idea is to identification step, because I have a sample. I don't know if it's malicious or not. I don't know if it's a malware or not, or it is, I don't know, it's document malicious or not. So this is a simple definition, right? Malware, it's a malicious software, and maldoc, it's a document malicious. So when I identify this sample, I can choose what the best method that I will apply in this binary, for example, or this file, right? So I will use an static analysis or dynamic analysis, right? This is just a concept. After that, I will prepare a report, because this is a very important step, because when after this, I executed this analysis, I can prepare a report, because of course, this is part of our job, right? Or part of the rule of the analyst or the threat hunter or something like that. So this report I can present to my manager, to my tech lead, or wherever, but I can explain all those steps that I executed when I made this analysis, right? But Filipe, if I have a report, what can I do with this information? So the next step is very important, because I can improve the defenses mechanism. Because at the end of the day, when you do this analysis, you can improve your defenses mechanism, because you will discover what kind of steps or way the attacker used in your environment. So if you see that attacker maybe using the bypass technique to exploit your firewall, for example, you can do different, you can improve the better configuration, you can use another different or the best practice, you can see the configurations on the settings in your tools that you use or the product that you buy, for example, right? So after that, you can create the good word, the cyber threat intelligence, you can build it. It's very interesting, because so if you have a small company, maybe it's impossible you create the cyber threat intelligence. But today we have many different softwares or open source products that can help you to build it, and why you can create, or why you could create the cyber threat intelligence. Because if you learn how this behavior of the attacker, of course, you can prepare more your defenses, the mechanisms. This is very important here. And of course, because the cyber threats or we have a strengthening in cyber resilience, we need to have this, because during our presentation now, probably we have another guy, another attacker or a threat actor creating a new different attack using a different techniques, right? Because of this, we have this life cycle, not life cycle, but the cycle of the attacker phase, right? So you can use in this method. So let's talk about statistical analysis. So what is a statistical analysis? So it's very interesting. Usually this is the first step that the analyst is using, because usually the statistical analysis describes the process of the analyzing a program code. It means you have a code, you can analyze all those parts of this code, if part of this code is malicious or not, or you can analyze the structure of this code. If inside this code we have a structure, if this structure has called some function, for example, you can find a DLL, what function this DLL is calling inside the system operation, for example, and the program itself doesn't run at this time, right? Of course, depending of the program that you can use, but usually it's this method. It's more safe, right? Because, as I mentioned, doesn't run at this time. You using like a manual command to try understand of this code, right? And when you talk about the dynamic analysis, it's another part, another different method. Usually it's based solely on behavior. It means in the interaction that the malware has when it's executed, or maybe a malware or maldoc in this case. This analysis, also known like a runtime analysis. It means you execute the malware inside a controlled environment, right? Or not controlled environment, but can use some tools or product. Maybe you can execute this malware inside this product, this code, not code, this tool. You can analysis of the behavior inside this controlled environment, right? So it can be easily automated. There is many sites today that already perform analysis of this malicious artifact, right? So using a small concept called a sandbox. It's similar. You have a virtual machine, and you execute this malware inside this virtual machine, and after that, we will see what those behavior this malware has inside this virtual machine, right? So let me see here. Yes, before talk about the physical and logical structure, I would like to share something here with you about the base, because it's important. If you remember in the beginning of this presentation, I talk about the identification step, right? So the idea here is to try understand about this point. So here I have many artifacts, right? I have an Amazon, I have a bill, invoice, I have a Linux, I have a PDF. This is a folder, not a file. And I have here read pill docs so. And so I have many different file here with different extension. So what command I can use here to try and find any information about this file? So I think many people know about this file command, right? So I can execute malware file command to try identify what this sample is, right? So here I have an Amazon, Microsoft Words, right? 2007. Let me try looking inside another, for example, view. It's a good friend. View, it's a PDF file, right? So let me see here about the Linux doc text. Maybe it's a text. So in this case, it's not a text, it's a ELF file. So it's different here because I have another interpretation here. So let me see another file, resume, .pdf. It's a PDF, perfect. So let me see here in a Windows. If I have another here, I have a sample file, sample. So here I have a PE32 executable, right? So as you can see here, I execute a file command. We have a identification process, but we have here some interesting point, because I execute here file Linux doc text, but actually it's not a text file, right? It's executable file. So how it's possible? Because here we need to understand about the base. That's my point here. When you execute this file command, in this case, file determine the file's type. But what is actually the correct information that these commands are using when executed in your environment? So here it's the manual. I know probably you don't like to read the manual, not not only in the Linux platform, but you don't like to read any different manual. I don't like, by the way, but I suppose that you don't like, right? So, but here we have important information to understand the base, right? Here we have important information. So let me explain more about it. The magic tests are used to check for file with data in particular fixed format. So probably we have a specific format to try find or to understand what kind of file is. It's not, of course, not based on the extension, right? And here we have the explanation. This file has a magic number. Here is the key, right? So all those files has a magic number, right? So this magic number, right, is stored in a particular place near the beginning of the file that tells the Unix operation system that file is a binary executable. So here we have a simple and very important explanation. So all those files has a magic number, right? And all those magic number are stored in particular place near the beginning. So, but how it's possible to understand more this? So here I made this very interesting thing to try explain more about this magic number for you, right? So I downloaded the file command, not a file command, I downloaded the database responsible to offering this information to the operational system. Of course, when you have in the Unix platform, as you can see here in my machine, I'm using this binary is compiled inside the system operation, of course. In my case, here I downloaded this source code, and I download the database of the file command right here. So let's see very interesting information here. Let me looking more inside the JavaScript. So here we have the file of the JavaScript, of course, and we have the definitions, some definitions important when I execute the file command, and this file command looking inside the database to try find the magic number of the JavaScript file. For example, let me put here this information. I will copy here, and I create in this simple file here, PDF doctext, right? And I will write here, and I will put the information in malware. Now, actually, I will do the different. I will put just a malware, right? And I will save, and I will look the PDF, right? Actually, it's a text, as you can see here, right? It's a text. But now I will change this information in the beginning because I learned now, or I read now this in the man of the file that all those files has a magic number in the beginning, in the particular place, right in the beginning of the file. So I will save here and the note. When I execute the file, take a look what happened. This is of course, is a text, but in this case, the magic number, it is identified by node.js script. Take a look. I will change another thing here. I will put just a simple sign here, and I will save again, and let's see what happened. Ooh, it's a Python script. Very interesting. So let's change something here. It's a PDF, move to pdf.py, and I say mode.pdf, PDF. Okay. So, yeah. Let me change here the privilege to PDF, right? And let me look again. It's a PDF, right? So let me call Python here, Python 3, PDF here, and bam, we have a syntax wrong error because it's not a Python, right? It's very interesting because It's not a Python, but if you see in the beginning, so let's see here, cat Python. Take a look here, the some regex. Because of this, because I put here the magic number. As you can see, we have a different here, different information, like similar regex. You can have a regex. You can see the informations here that you can use here. For example, let me copy here, and I will change one more time. Here, it's a Python, right? It's a Python. I will cut here and I will save. As probably you see, in this case, in ASCII, I'll take a look. It's very interesting. It's in this case, it's different because probably we use just only like a policy inside the database, right? Not a policy, actually. It's one of this rule. I think it's better this rule, right? So let me change the one more and the last time here. Yes, it's no. I will cut here. I will put the %PDF because this is our challenge here today. And I will save here and let's see what happened. Whoa, it's a PDF document. But in the extension, it's a Python. So all those, so I did it during this presentation. Basically, let me talk with you. I did it during this presentation because you need to understand all those bases. As I showed during this presentation, you see here, we saw here actually the file or the identification step. It's very, very important, right? Because you need to understand inside of the file. Probably you know about the file command, but the idea is here is it's try to explain you how it's important to understand all those bases, right? Because, for example, let me share my screen one more time with you here. So let's look inside this one more time here. I think you know, but probably so. Maybe some people don't know right here. Let me look inside this mod here. We have here another interesting, very interesting information. Here. Okay. Whose format, or in this case, the magic tests are used to check for files with data in particular fixed format, right? I already read it. The canonical example of this binary is a binary executable compiled program because it's inside of the system operation, right? And h.out file, whose format is defined in elf.h. Here's another format, and possibly execute.h in the standard included directory. So let's see, because here I can see, I will copy this format, right? So let's see if let me return our, yes, locate this file. Let's see. So this binary actually, it's in this path, user include elf, right? I will read here. So, take a look what is important here. This file, I think you can read. This file defines standard elf types. So take a look what is important inside this file, right? So this file defines standard elf types, structures, and macros, right? So here we can find the correct structure of the elf file. If you read below, if you see here, you can see the number of the bits used, right? The words, X words, and here you can see the interesting information. The elf file headers, I know this presentation it's about PDF, but take a look about the man or the information that we found and that we found inside the map. The elf file header better, this is the file, the elf file header. This appears at the start of every elf file. It means appears at the start, not ever, start, that is in the beginning of the elf file. What started in the beginning in this case? We have in the beginning of the elf file, we have 60 bytes, right, or bits in this case, and we have this structure, 60 bytes, right? And the first array of this bytes is called e-ident, and you will find the magic number and other informations inside this 16 bytes. We will find all those informations. You see? So magic number and others information. What kind of information you can see? Here, let's see. Okay, this field is fields in the e-ident array. You will find you can find the file identification byte. The first is 0. The second file identifier is E. The third is L. In the 4 it's F. I will show you another thing to you here. Let me open. You see file Linux 32, right? And let me using file. I use a file, right? And if I use here XD and 32 Linux, right? Okay, no, it's not Minos, not Minos. Here. Yeah, now it's correct. So take a look here. The 4 bytes, the first is 0. The second is E. In this case, it's E here, as you can see. The third is L. It's L here, right? And the 4, it's L. You see? You can see? So that is important. You need to understand this because I read the man of the file and I found many information is important of the structure of the file. But if I didn't read this information inside the man, you know, how it's possible to understand the basis? Of course, I need to run, I need to study, I need to read actually. I need to study about all those bases. This is a main point here when you talk about the malware analysis, when you talk about the red teams, pen testings, defense team like a blue team, or threat hunting teams, or SOC teams, or whatever teams. You need to understand all those bases, right, people, right? So let me return here my presentation, right? Let me return here the structures, right? So let's talk about the physical and logical structure about the PDF. Usually we have 4 parts. The header, usually it's very common in wherever binary. We have a body, we have a cross-reference table, and we have a trailer, right? So this is the main part of the PDF. In the beginning of the file, we have a version number, right? And you have objects, you have images, you have a cross-reference table. This is a location of the object inside within the file because it's random, right, the access. And we have a trailer. It's a location of the certain objects inside the body. It means you have a mainly body and you have many objects inside this body, and all those objects is or are in this case are reference one and another, right? So let me show you the demo to you. So I will use here some tools to help us in this demo. I will execute the PDF ID. It's very known tool. It's created by DDA Stevens, right? and I will execute this in Linux. If you see here, the first information that we found in this demo, as you can see here, we found the header, as I mentioned, the structure, right? So the second information here, we found the 15 objects, right? So we have 15 objects, and of course we have the same 15, right? So maybe you have here, not maybe, you have two and extreming, because you have a two extreming, and here we have a cross-reference table. And if you see here, we have others important informations, of course. All those informations are inside the DDA Stevens blog, right? You can find all those explanation more inside the blog page of the DDA Stevens, right? But here, the slash or slash page, slash encrypted, slash object streaming, slash JavaScript. Here, we will find interesting informations. All those informations are inside this mainly part of the PDF. So here I have an important tip for you. Probably when DDA Stevens created this tool, he studied a lot about the PDF structure, and of course, he analyzed probably many malwares, and he found many information inside this samples. Yes, and when probably, of course, I'm supposing, because I'm thinking the idea of the base, right? So all those slashes are information inside the main point, the main object, and these tools only just will possible to create it because probably the DDA Steven, the main creator, right, knew about how this tool works, right? Or not tool, but how this PDF works. It's the main point here, right? So let's continue to see here. And we have here one page, and we can see here we found 5 JavaScript inside the PDF, and we have an open action. Open action is a very interesting point here. If you read in the website, if you read, of course, we will see the open action is responsible just the user don't need to click many times in the PDF file. When you have this open action inside the PDF, the only action that user needs to do is download the file, for example, from the email. If user receive an email and click in this PDF and download in for example, in the machine, in the Bitman machine or in the own machine, because they have this file has an open action, when the user download this file will execute this open action. In this case, it will execute something inside the PDF, right? So I can suppose, of course, if have an open action, and if have JavaScript inside the file, and this file just have an only page, and we have some information encrypted, probably it's malicious, but I don't know exactly what is malicious, but it's malicious. I will execute after that the PDF parser. It's another tool created by DDA Stevens. I set the run because I would like to see all those information inside this PDF. And here I will explain something to you. As you can see here, the header. And after that, you can see here the object 1. And here we have object 1, take catalog. And here we can see the referencing. Here's a very interesting point, because the object 1 is referring object 2, object 3, object 4, object 5, 6, and 7, right? And what this means in this case, here it's an interesting point. Do you remember when I explained about the structure? If we have the object, the body. Inside the body, we have objects, reference, or inside or located inside the file, right? So many times no, but all those files or those objects are reference one another, as I will show you here. So take a look. In object 1, we have a JavaScript, and we have an open action. Let me return here. We have an object. In this first step, it's an open action, is these open actions after this action executed in the victim machine is executed or will be executed at JavaScript. So here there's evidence that is malicious because the user, when downloaded the file, after that will be executed an open action, and after that will be executed the JavaScript, right? So let's continue to see. So okay, we have an object 2, 3, 4, 5, and take a look here. Let me return one more time here because I have here another information, important information here. Okay, take a look here, object 4. In this case, object 4 references object 8 and 9 because before we just have an object 1 until 7, but now we have an object 8 and 9, 2 more objects, right? So let's continue in object 6, 4, and here we have another reference. Object 7, we have another reference. In object 10, and inside the object 10, we have a JavaScript. You see? Okay. So, and here, let me put, in object 9, take a look what happened here. We have an object 4 because, you know, we have this reference between the objects. And here we have another reference, 11, object 11. So we have a beginning, this is the 1 object, and now we have the 1 until 11, right? But when we executed the PDF ID, do you remember how many objects we have inside this file? 15. Don't forget this, right? Here, take a look. We have the object 10. Inside the object 10, we have another reference, object 12, right? And we have probably here we have a JavaScript. Okay, take a look here. In object 11, we have here we have another information, different contains a string. So probably we have something inside this string, right? And when we have this flag the code, because we need to decode the information, right? And here we have a length. It's like a size of this kind of string, right? So maybe when you see here the size, it's small, okay? And inside of object 12, we have another reference in object 13. And inside this object 13, we have a what? A JavaScript. So let's continue to see what happened. And here, take a look. Contain string in object 13, and you have the same flat decode, but here we have a big size, 3151. It's a big size, right? So here maybe I need to looking more deeply, right? So okay, and we have another object 14, the last, then maybe almost the last, right? And because we have 15 objects inside here, and we have here the object 15. Okay, so we need to see more deeply of the 13 objects, right? So next step, I will execute a PDF TK. It's another tool. Actually, this tool is not from the Steven, but it's another very interesting tool. I will basically here the command I will execute. I will collect the output of this sample, all those information, because I will extract of this information here, and I will uncompress all this information inside this dump doc text, right? Okay, I will execute this. So now we need to see what information we have inside this dump. And take a look what we will see here. I can see all those information. And take a look here. Here we found the first technique used by the attacker. So here we can see the JavaScript obfuscated. So what the next step? I need to disobfuscate of this information. But here the attacker used this technique, right? So I will see here some informations. I see some parameters that the attacker used in this demo, in this case. So I will copy the code, and I need to, of course, disobfuscate this code to try find some information, right? So I will set this file in HTML. Why? Simple, because when we execute any web applications, usually they use in the JavaScript and HTML and CSS and something like that, right? So I found here the evil parameter, and I will using this evil parameter to try to disobfuscate this code, right? So basically, I will see inside this parameter, and I will change to the document writer, right? Because document write actually, because I will need to, the idea here is to try rate what information I can find inside this JavaScript obfuscated, right? So take a look what happened here. It's very, very nice what happened here. So after that, I gave the privilege access to access this information, of course, and I will execute this payload.html. So take a look now what happened here in our demo. I will show you. I will found the var, a variable payload. As you can see here, we found a payload, right? So what means exactly in this case? We found here a payload malicious. So first of all, we have a PDF file. Inside the PDF file, we have an open action. This open action, after that, will execute the JavaScript. This JavaScript was what? Obfuscated. Inside the JavaScript has a payload. Payload is responsible to, load this payload inside the virtual machine, and this code is responsible to reverse to call back to the CNC in this case, right? So now we have a payload responsible to, load this information or to download this information actually, to download this information inside the virtual machine. And this payload, in this case, this payload, as I'm showing to you, will be responsible to call to the CNC from the attacker or the threat actor. So now I could to finish my analysis, but here we have an interesting point. If, let's suppose, if I have the payload, I can try to find this IP responsible to this attacker, right? So after that, what I see. So let's see what kind of information I can try and find. So I see here some information, right? Like a percent here and some numbers maybe. So the next step, I created another file here, right? I called it real payload. Perfect. And I would generate, I copy and paste all those information inside this file, and I using the set to cut this percent here, because my idea here is to try to clean the file. Take a look here, the var, the parameter, and I cut some information, and here I cut many others like a slash, like a percent, and I copy this information, and I arrived in a Unicode code here. So now I have this Unicode code. It's another technique, because the attacker in this case uses it's of course it's not new, but it's old. The Unicode code based on UCS. Yes, actually UCS. Yes. No, EC2 UCS. Yes. So it's Unicode. It's based in 2 bytes, different of the ASCII. It's because ASCII it's very common now. So this is here. It's very interesting. So I use in many Linux platforms. So I will see now another platform, Mozilla, in a Windows machine to show you. So here we have the same code, right? So we have aquí all those percent here I need to cut that I did in the Linux machine, right? So I cut this information, and here I have the pure, pure Unicode. So after that, so do you remember I had a JavaScript obfuscated. I disobfuscated this code, and after that I generate a payload. This payload, I found the Unicode code base in UCT in UC2, sorry. And inside this information, I generate an Hexafile doc binary using this tool, Mozilla, right? So after that, take a look what I did. I using a short search, it's another tool provided by DBA Stevens. I execute an Hexafile, my file that I generated here, in this case, and I called HTTP protocol. And take a look here what I found. Basically, I found the CAC from the attacker. You see, this attacker was, in this case, in Estonia, Europe, right? So now we finish our presentation, and I will show you here my contacts again on the social medias. And just to finish the presentation, so let me talk with you. We had a sample because we have a PDF file. So we found a JavaScript inside the PDF file. We have an open action. We had an open action inside this file. This PDF had an open action, and this open action called a JavaScript. The JavaScript has, or had in this case, a JavaScript obfuscated. Inside this JavaScript obfuscate, we had a payload. This payload, it will be downloaded on a Vitman machine, right? And this payload has a Unicode code, right? It's old, of course, but it is another technique. And after that, I generate a hexa binary, right? And after that, I use ensure to collect the HTTP protocol to find the CAC from the attacker. In this case, a command and control, right? Responsible to set or to send this attacker to the Vitman machine. So we finish our presentation. If you have any questions, so please let me know. I am available to you. Thank you one more time for stay with me during this presentation. So again, if you have any question, I am available to you.